In our last video, we looked at how when price is changed from $1,000, how you move along the flat demand curve. So you start at point A and you move along the flat demand curve. So if you raise price from 1,000 to 1,100, you move to point B. If you lower price from 1,000 to 900, you move from point A to point C. Now this has some implications in terms of price and output. So in other words, price and output in this market structure, in an oligopoly market structure, is more stable than in perfect competition or monopoly. And the kinked demand curve helps explain why that is. So let's look at this. Again, let's assume that you start at point A and you're charging a price of $1,000. Now, when you raise price, you don't move along the steep demand curve. You move along the flat demand curve. Now, the flat demand curve is relatively more elastic, price elastic, than the steep demand curve. So do you remember our talk about, when we talked about price elasticity, when a good is price elastic, the rubber band stretches. So in other words, if you raise price, demand falls a lot. So can you see how we're at 8,000, right? When you raise price to 1,100, demand falls a lot. And it falls so much, total revenue falls as a result. And you can see here, the rubber band stretches, price elastic. So when you raise price, you lost money in terms of revenue. Okay, what about if you lower price? Well, let's look at it again. Let me just erase some of this here. Now, what if you lower price? Again, let's start with the price of 1,000. And what if you lower it to 900? Well, now you move from point A to point C. So you lowered price, and now notice how when we're lowering price, we're moving along this steep demand curve rather than the flat demand curve. Now, steep demand curve relative to the flat one is price inelastic. So if it's price inelastic, you lower price and you don't get much of a response. And so total revenue falls again. You thought by lowering price, you're going to get a lot of new customers, right? But you didn't because your rivals copied you. And as a result, the rubber band does not stretch, it's inelastic. So you lowered price and total revenue fell. So think about this. When you raise price, total revenue fell. And when you lowered price, total revenue fell. So in each case, raise price, lower price, total revenue always falls. So this is an example of why, a graphical example, why oligopolists do not like to compete based upon price, because anytime they change price, revenue falls. So they have to find another way to get an advantage over the rivals. Now, the kinked demand curve is not the only way to explain why price and output are more stable. Like all producers, oligopolists want to maximize profit where MR equals MC, right? And the kinked demand curve, since it's really two demand curves, it also has two marginal revenue curves. And that also could help explain why price and output are more stable. So let's take a look at this. Let's look at the kinked demand curve. So here, and this may be a little bit hard to see, but this is the flat demand curve right here, D1, and this is the steep demand curve, D2. Let me get rid of those now. Go away. Now, I want you to focus your attention on only the relevant parts of each demand curve. So for example, this is the relevant part for this part of the demand curve is relevant right here. So I just highlighted it right here. Because this demand curve is relevant for up to point A, the marginal revenue curve associated with this demand curve is relevant to that point. So here's the marginal revenue curve for that part. So this marginal revenue curve, which I just highlighted right here, let me highlight it in a different color. I'm going to erase this, and I'm going to try to draw this in another color. Well, that may be a bit difficult. No, I could do it. I'm going to make it red. So this MR curve is associated with the demand curve above it. Now let's look at the demand curve beyond point 8. This is the steep demand curve. Now the marginal revenue curve associated with this one, again let me change my colors, is going to be this one right here. So we've got a marginal revenue curve that goes like this up to point F, and then from point G it goes here. And you've got this kind of gap in the middle, right? This is what we call the MR gap. Now the MR gap has some implications because the MR curve really looks funky now. It is flat up to here, then goes vertical, then it is steep down to here. Now the reason why this is significant is because a profit maximizing firm will produce up to the point where MR equals MC. Now, if MR changes, output changes. If MC changes, output changes. This is true for perfect competition, and this is true for monopoly. This is not necessarily true for oligopoly, and I'll explain why. If we draw let me get rid of some drawings here. If we draw let me get another color. I'm going to use green. If we draw a marginal cost curve that looks like this, well, we find where MR equals MC, and that's where they cross, right here. See this? Do you see the MR curve is vertical here, and the MC curve is right here? And we find the profit maximizing rate of output by going down here, and then to find price, we go up to the demand curve, and we move over here. Now, what if we raise costs? If costs go up to MC2, what we're doing is we're raising costs here. Now, in perfect competition, if you raise marginal cost, Q would change. In monopoly, if you raise costs, both Q and price would change. Not necessarily here, because we have a new intersection right here, but notice how the rate of output doesn't change. And if we go up to here, price doesn't change. So as long as marginal cost shifts within this gap, we have no change in P, and we have no change in Q. So this is another way to demonstrate why price and output are more stable in this market structure than in other market structures. Modest changes in costs don't always lead to a change in P or Q, as opposed to perfect competition and monopoly, where any change in costs led to a change in P and Q. And economists call this the cost cushion. So again, the cost cushion means when costs go up, as long as they go up within this gap, firms will not raise price to try to cover those costs. To explain this in a more plain manner, if you are an airline and your fuel costs go up, so fuel costs go up for the entire industry, let's say, you're not willing to raise price to try to cover those costs because you're afraid that if you're the only one who raises your price, you may lose market share to your rivals. So firms are willing to accept lower profits to protect market share. Up to a point, because if I keep raising costs, let's say to here, MC4, you could see that we do have a new intersection. So let me go back to here. You could see how when I went from MC1 to MC2, MC1 to MC2, we didn't change P and we didn't change Q. But if I raise it to MC3, we will change price and we will change quantity. Notice how we have a new intersection where MR equals MC, and that leads to this quantity and this price. So that's why I was very, very careful with how I phrase this. Modest changes in costs don't always lead to a change in P and Q. But you can eventually get to a change if you keep raising costs and that shift moves out of that gap, the MR gap. That's what I'm trying to say there. Now, oligopolists would love to cooperate, and let's say I'm an oligopolist, you're an oligopolist. I secretly tell you, hey, raise your price and I'll raise my price and we'll both make a lot more money. This could happen, but there is difficulty in coordinating this because I want to maximize my profit, and you want to maximize your profit. If we both agree to raise price, but I cheat and I don't, I could steal some of your customers. So we agree to raise price. You raise your price, but what I do is I don't raise mine. Because of that, I can get some of your customers. And this makes it very difficult to coordinate behavior, because if there's incentive to cheat and there's no effective punishment mechanism, it's going to be almost impossible to cooperate. And that's where we lead into our next topic. We're going to be talking about game theory. And game theory is a way to try to figure out what to do when your rival can respond in a number of different ways to your actions. So in other words, we're going to be covering how to handle the issue of interdependency in an oligopoly market structure, and we're going to use game theory to do that.